today class we are going to discuss about chirality. Chirality is defined as a molecule which is optically active, which is superimposable on mirror image is known as chiral compound. Chiral compound. So a molecule which is optically active, OA means optically active, which is non-superimposable on mirror image is known as chiral compound. So next we are going to discuss about achirality. So it is opposite to the chirality. A molecule which is optically inactive, which is superimposable on mirror image is compound known as achiral compound. Okay, so we can take some examples. So chiral means in Latin language. Chiral means in Latin language handedness. Handedness. So examples for chirality is the examples for chirality that is hand and some alphabets like O, A, next sphere and cube, sphere cube. So next examples for achirality compound are alphabets like P and E. So first we discuss about example for chirality. So the left hand, which is our left hand. So to the left hand, when I place a mirror, so a mirror image, so right hand mirror image will be formed. Right hand, so this is left hand and this is right hand. So right hand is the mirror image for the left hand. So after the forming of mirror image, when I place this left hand on the right hand, so it does not fit exactly. So that is non-superimposable. So that's why our hand is non-superimposable. So which is non-superimposable. So similarly, like an O and A compounds after forming of mirror image, so they are superimposable. So that's why these are achiral compounds. Achiral compounds. So some space that means spherical. So golem and some cubes. This is the cube. So when I forms a mirror image to this one, they are superimposable. After forming mirror image, they are same like as the first image, first one. So that's why these are achiral compounds. So non-superimposable on mirror image is chiral compounds and superimposable one on the mirror image is a achiral compound. So next we are going to discuss about chiral compound. So this chiral compound concept was developed from the tetrahedral structure of carbon. So tetrahedral structure means a carbon which is attached to four atoms or four groups. So in the tetrahedral shape. So this is the tetrahedral shape. So if a carbon is attached to four different groups, so that compound is known as the chiral compound. So that carbon is known as chiral compound. So which is upon mirror image is non-superimposable. So for this mirror image, so D and center C as it is in its position B and A. So after forming the mirror image, so when I place the first compound on the second one, so its mirror image is not exactly as the first one. So there is a mismatch with the B and D. So B and D. So that's why 1 and 2 are non-superimposable. So this compound is a chiral compound. So with one example, we discuss this chiral compound. So example for this compound is we are taking lactic acid. So the IUPAC name of lactic acid 2-hydroxypropanol. 2-hydroxypropanol. So 1, 2, 3. So 3 carbons with is a propane. So at the second position, hydroxyl group, alcohol. So satisfy the remaining carbons with hydrogens. So hydrogen and next to CH3. So this carbon is a central carbon because it is attached to one methyl group, one hydroxyl group, one methyl group. Sorry, C hydroxypropanol. So 2-hydroxypropanoic acid. Sorry, 2-hydroxypropanoic acid. 2-hydroxypropanoic acid. So this is COOH. Okay, so I am writing the structure clearly. So central carbon OH and CH3. I am writing this carbon lactic acid structure which is having the chiral carbon in the tetrahedral structure. So this is the chiral carbon. It is represented with the star mark. So when I place a mirror before this carbon, so its mirror image will be so, and OH and H will be in their positions only. So COH come closer to the mirror. So CH3 will be far from the mirror. So this is the first compound. Its mirror image will the second one. So this is lactic acid 1, lactic acid 2. So when this first compound and the second one, there is a mismatch with the carboxylic acid and methyl groups. Okay, so exactly not fit. So chiral compound is a concept like and left hand and right hand non-superimposability character. So there is a mismatch with the carboxylic acid and methyl group. So that's why this lactic acid is an example for chiral compound. So which is optically active. So there is non-superimposability takes place after forming of mirror image. So another example for chiral compound is 2-hydroxy, so lactic acid, and some more examples are there for this chiral compound. So another example is 2,3-dihydroxypropanol. So another example. So with this we are completing the chiral compound. So I think all of you understood. So please. So this is about the chiral compound and achiral compound. So we can continue the next session with some more topics. So if you like the video, please like, share and subscribe my channel for more updates.